Assalamualaikum, and my name is Muhammad Ilmam. Today I will be starting the report presentation for my group, which is minor loss in pipes. So introduction in fluid mechanics and hydraulic engineering. Understanding the minor head loss in pipe system is essential for designing efficient water distribution networks and industrial fluid transportation system. These losses caused by components such as pipe bands, fittings, valve, and other disruption to the smooth flow can significantly impact the overall energy efficiency of a system. The loss coefficient KL quantifies the energy dissipation due to such components, while the minor head loss HLM represent the corresponding reduction in hydraulic head. Right, next for the objective is to determine the loss coefficient KL value and minor head loss HLM in pipe components fittings for different water flow rates, pipe diameter, and pipe bands. So next for scope, the first one is identify which inlet flowing pressure H1 and outlet flowing pressure H2 and connect the manometer tube. Second is determine 5 suitable flow rates Q by adjusting the outlet valve. Third is evaluating the impact of different pipe bands angle, example 45 degree, 90 degrees on the loss coefficient and minor head loss. So for the theory, in piping system, fluid flow at varying flow rates often passes through fittings, bands, or abrupt changes in area. This creates additional head losses, known as minor head loss (HLM), primarily due to flow separation. By simplifying the Bernoulli equation for a horizontal pipe, Z1 equal to Z2, the pressure loss P and total head loss HLT can be calculated. So the image here show all the formula from equation 1 to equation 5, and here we are stated what is what. Okay, example as P1 minus P2 equal to pressure drop between 2 point PA. Okay, the value of KL is strongly dependent on the geometry of the component considered, as well as the fluid properties include the RE, Reynolds number, and the mathematical function of them can be expressed as follows: KL equal to V geometry RE for equation 6. And here is the figure of loss coefficients for flow through sudden area changes. We have contraction and expansion. Alright, next, the KL value for fluid flow through sudden expansion and contraction is derived using the continuity equation 7, momentum equation 8, and energy equation equation 1 for the control volume in figure 2. So as you can see, not equation 1, equation 10. As you can see here, from equation 7 until equation 10, and the list of what is example as P1, total pressure is small cross section of upstream PA.
So for methodology, first we should determine the direction of water inflow and outflow and open the inner valve of selected pipe section, switch on the pump. So after we switch on the pump, we slowly open the control valve, turn counterclockwise until maximum and wait for a while to remove the bubble. So then we should identify which inlet flowing pressure, which is the H1, and outlet flowing pressure H2, and connect the manometer tube. Then we got the value of H1 and H2 in millimeter. The unit is millimeter of the inlet and outlet of the water manometer. And record the volume water collected at the tank with the time for measurement of the water flow rate Q of water. Then determine the 5 suitable flow rate Q by adjusting the outer valve. And after finish, we should take up the manometer tube first to avoid the bubble and open the inlet related valve for the next pipe and close any valve which are not related to the water flow. Repeat the step 5 until the step 9. Once finished, take out all the connected tube from the system and fully close the control valve and switch off the pump and the main switch. So if the bubble in the system or manometer is full, we should connect the manometer tube to any pipe section and fully open the inlet and outlet valve for the pipe and open the vent valve at the top and let the bubble to come out. And once done, we should close the vent valve and close both the outlet and inlet valve of the pipe, then turn off the main switch. And to setting zero position of the manometer, we should open the vent valve at the top 2 rotation. Slowly open both of the drain valves, then let the water at the center of manometer scale, then close and also close the vent valve, then turn on the main switch. Experimental setup, the apparatus that we use in the experiment is the inlet valve, 2-tube manometer tube, tester pipe section, and the outlet valve.
Okay, this is our proof of our result. Okay, we record the Q at and the delta H emitter for the sudden enlargement, sudden contraction, Y type, and T type also. And also angle 90 and bend 90, also angle 45.
Alright, next for the discussion, I get the part calculate the minor heat loss HLM and loss coefficient KL value for each of the pipe components fittings. And note that for major loss HL calculation, set the temperature of flowing medium T equal to 36 degrees C and determine the coefficient of friction F using a formula basis. So here we have the for the sudden enlargement formula, sudden result, sudden contraction, Y type, T type, and 2 times angle 90. And next we have 2 times band 90, and the other one is the other one is 2 times angle 45.
Okay, our discussion tool for this experiment is to discuss the effect of different water flow rate, pipe diameter, and pipe bands on the volume of loss coefficient, that's KL. Okay, the effect of different water flow rate, we observe the trend in result. As the flow rate increase, the head loss increase also for the pipe configuration, and we observe the relationship with KL. For example, the KL depends on the ratio of head loss to velocity head. And this is our first part. Okay, for the second part, we discuss about the effect of pipe diameter. We discuss about the impact of on the flow dynamic that is larger pipe diameter result in reduced flow velocity and so on. And based on our observation, that small diameter amplify the effect of velocity change at fitting, leading to higher KL. And the third part is the effect of pipe bands. And we do a comparison between sudden enlargement and contraction, Y type and T type, and also the bands, for example, 90 degree and 45 degree. And we get a result that is sudden contraction exhibit the higher level HL, and followed by T type, Y type, and sudden enlargement. This reflects the nature of flow resistance processed by each configuration. So, as a summary, higher flow rate amplified head loss due to increased turbulence and friction, leading to higher KL. Smaller pipe diameter result in higher KL as velocity increase for the same flow rate. And among fittings, sudden change in cross section, for example, enlargement and contraction, cause more energy loss than gradual bends and or transition.
So for discussion 3, the question is briefly discussed on the factor contributing to the error on inaccuracy in experimental data and the possible recommendation to improve the existing results. So parallax error occur when manometer reading H1 and H2 are taken from the wrong angle. So this will lead to the incorrect calculation of the manometer differential height delta H affecting the differential pressure delta P, total heat loss HLT, minor heat loss HLM, and the pipe fitting loss coefficient KL. So the recommendation to reduce the parallax error is always read the manometer at the ice level and use digital sensor for automated readings and repeat the reading and average them for consistency and regularly calibrate the manometer for accuracy. So unstable water flow rate QR is another key factor that contributes to the error in experimental data. Fluctuation in water flow cause the constant minor variation in the manometer water level H1 and H2, thus leading to the erroneous of the manometer differential height delta H values. So this propagates inaccuracy in other calculated parameters like the pressure drop and the heat loss. So recommendation to reduce the error is we should let the water flow steadily through the fittings before connecting the manometer and use a large sump tank to improve the accuracy of the tank and the flow rate, and install the flow control valve to stabilize the water flow and ensure the manometer readings are steady before recording the data. The two main sources of the error, parallax error in reading manometer level and unstable water flow rate can significantly affect the accuracy of calculated parameter like the delta H, head loss, and the fitting loss coefficient. So by ensuring the proper reading technique, which to stabilizing the stabilizing the water flow and using the reliable equipment, this error can be minimized by reading to more accurate and reliable experimental results.
So now I'm going to present the safety procedure in our experiment. First, in general, we have to wear a lab coat during experiment to protect ourselves from getting wet. And since the experiment, we are going to measure the pressure in the pipe. So we have to ensure that the pipe and fittings are securely connected to avoid leaks and split. And we have to always monitor the pressure gauge to avoid over pressurizing the system. Uh, for conclusion for our experiment, in this experiment, we have determined the coefficient loss value, which is KL value, and the minor head loss in pipe flow with different material, rate flow, flow rate, diameter, and bend. As the result shown, the KL value is increasing with the flow rate and turbulences. Therefore, in order to increase the accuracy for KL value, we shall avoid the unstable flow rate when taking the measurement. This is all the reference we're taking in our experiment. And that's all. Thank you.